Hello everyone, I'm Steve Champalia. I'm an Associate Professor of Art and Design Education at Case Western Reserve University. And in this series of videos, you're going to learn about the Scratch visual programming language, how it's used by teachers and students to integrate programming and the visual arts into various subject areas. And also, you'll learn to get started so that you can actually teach and make your own projects with the Scratch visual programming language. What I'd like to start with is a presentation about Scratch itself, where it evolved from, and basically just to give you, provide you a little bit of context about what a visual programming language is.
This is code. It's a text-based programming language. Every line is an instruction that tells a computer, microprocessor, or microcontroller what to do. Code drives nearly every function of our lives in the Western world. Laptops, smartphones, tablets, video games, cars, microwaves are all controlled by code. This is a visual programming language, or VPL for short. You can see that the syntax has been simplified. The logic of the instructions are the same, but the way that the language is represented has been altered. It is now primarily visual rather than text-based. It makes programming more accessible and democratic. This is Seymour Papert. He was the first to articulate this idea. He agreed with Paulo Freire that schools cast students in the role of passive recipients. He also believed that computers could update and extend John Dewey's campaign for a more active and self-directed learning style. Papert created the Logo computer language in 1969 to explore these ideas. Logo was initially used to drive what you see here, the turtle. The turtle had two manifestations, one physical and one virtual. As you can see in this picture, the turtle looks like a little robot, and via a wire, or a group of wires, it's tethered to this computer. On this computer was running Logo, and also a virtual representation of the turtle could be seen that mirrored the turtle that was in the physical world. So essentially, if you look at the top right of your screen, this is what the turtle in its virtual form would look like on the screen. This is also what the language would look like. It's very simple. You would just say, have the turtle go forward so many steps, turn right or left so many at an angle of so much, and then go so many steps again, go again, turn again. So essentially, you were telling virtually the turtle on the screen to move around, and it would leave a line behind it, like a trail. And with the physical turtle, you could actually affix a marker to it, as you see on the top left, and it would leave behind essentially a trail of all of its movements. So here you see on the screen again, you see the virtual turtle, right? And you can see that, forward 100 steps, so to speak, right turn 90 degrees, forward 100 steps again, essentially making a square, telling the turtle to make a square. Now, Logo is an articulation of Papert's theory of constructionism, and it's basically based upon Piaget's theory of constructivism. And Papert believed that when individuals physically manifest their construction of new knowledge through the construction of a tangible object, it puts the learning that takes place in their mind into the physical world, and it makes it more meaningful. So essentially, he believed that by using Logo and having, having a virtual result of this visual result from the programming, in this case, you can see these drawings that resulted. The students essentially would more deeply understand programming and the visual arts together, or how the visual was integrated with the technological. So students essentially learn to program through the creation of art. So here you see one example, and then another. So you could do some quite complex programming. I shouldn't say complex programming. You can make some complex illustrations with some very simple programming commands. So what happened to the turtle? Well, over the ensuing decades, it morphed into, with funds from Lego, the Lego Corporation, it mutated into Lego Mindstorms in the early 1990s. And here you see the Mindstorms. You might be familiar with these. They use them in robotics competitions in middle schools across the country. Essentially, that piece in the center that says EV3, that is the brick or brains of the Mindstorms. And you program it using a language that is a derivative of Logo. And it can also plug in sensors like a color sensor, a touch sensor, and then you can plug in outputs such as a motor that can drive other Legos that you hook to it or other objects or materials. Essentially, it's very robotic in nature. Now, the Mindstorms focused more on mechanical construction and less on creative expression, unlike, how Logo was originally conceived. It could be used in creative ways, but often it was not. Well, they're still around, so they're often still not. The instructions for Mindstorms are prescriptive. They're definitely gendered, as you can see, and marketed to boys, very militaristic in style. The leader of the development team of Mindstorms is Mitch Resnick, who you see here, and he had some misgivings about how Logo manifested itself in the Mindstorms in that very sort of gendered, prescriptive way. So he commenced to redress this problem by developing the Pico Cricket. The Cricket really focused on creative expression, and it was intended to integrate art with programming and engineering. So here you see the Pico Cricket. It's very similar to the Mindstorms in that, up at the top left, you see the Pico Cricket itself. That's just like the Mindstorms brick. You program it. It has inputs such as, sound sensor, light sensor, touch sensor. It has outputs like it has a motor again to drive Legos that can be hooked to it or other materials. It could play sounds. You could program music on it. It had a display with numbers, or a numerical display. So the programming language that was developed to be used with the Pico Cricket was called Pico blocks. And Pico blocks were the first visual programming language. So in other words, you can see that instead of actually having any written code, it was all done in blocks that resembled Legos, right? You snap them together with the commands in the sequence that you wanted them to happen. And they actually made the Pico blocks themselves very colorful like Legos. So the idea was that it would appeal to young women as well as young men, so it wouldn't be so gendered. And you can also see that unlike the Mindstorms, which has these very prescriptive step-by-step instructions, the Pico Crickets just came with what they called placemats, and they gave a prompt. And the prompt didn't tell the user what to do, but just sort of suggested something. In this case, make your dream house. You can also see that it highlighted, these placemats did, the use of materials beyond just Legos and the actual Pico Crickets or Mindstorms themselves. So they actually suggested integrating other materials into your creations. So what did people do with these? Well, I can show you some examples that were made in middle school art class of my own, where students found materials, some that they brought in and some that and they made along with some Lego parts to basically make their own found object interactive kinetic sculpture. So here's one. And a nice close-up that I can touch. I'll play for you. Here's another. That the students actually programmed those, brought in the prompts, and it was totally self-directed. I just gave them the prompt of using some found materials and movement and sound, create a sculpture using the Pico Cricut. So anyway, the Pico Cricut unfortunately has been discontinued, but in its place has appeared the Little Bits. You see them right here. Now, the Little Bits can be programmed as well, but the programming language that is used to drive the Little Bits is Scratch, which is the most popular derivative of the Logo computer language. Scratch was developed also by Mitch Resnick, and it built on the concepts he introduced in the Pico Cricuts, and particularly the Pico Blocks software that were used to drive the Pico Cricut. Scratch is intended to further integrate art and programming and promote the 4 P's of creative learning: projects, peers, passion, and play. Scratch was designed with projects in mind. Young people have created and shared more than 5 million projects in the Scratch online community, with roughly 10,000 new projects every day. As young people create Scratch projects, they engage in the creative learning spiral that you see here. They first imagine what they want to do, create a project based on their ideas, play with their creations, share their ideas and creations with others, reflect on their experiences, all of which leads them to imagine new ideas and new projects. As students go through this process over and over, they learn to develop their own ideas, try them out, test the boundaries, experiment with alternatives, get input from others, and generate new creative learning spiral ideas based on these experiences. In the process, they develop as creative thinkers. When Scratch was launched in 2007, the Scratch online community was launched at the same time. So from its inception, interaction with peers was a central element of Scratch. The Scratch online community serves 2 roles. It provides an audience. When young people share their projects, they get feedback and suggestions from peers in the community. At the same time, the community provides inspiration. When young people try out projects made by their peers, they can get new ideas and even borrow scripts and images for their own projects. Scratch was designed so that it could be easy for people to remix one another's projects. All projects in the Scratch community are covered by a Creative Commons license, so that people are free to build on one another's work and ideas as long as they give appropriate credit. More than 1/4 of the projects on the Scratch website are remixes of other projects. Passion. Young people have shared more than 5 million projects on the Scratch website, including stories and games, interactive birthday cards, anime comic strips, interactive newsletters, virtual tours, dance contests, public service announcements, and much more. This diversity of projects is an indication that young people are working on Scratch projects that they really care about. It is also a reflection of the diversity of interests of young people. With Scratch, young people from many different backgrounds with many different interests can all work on projects they care about, And when people work on projects they care about, they tend to work harder and learn more. Play. The Scratch development team thinks of play as an attitude and an approach for engaging with the world. They associate play with taking risks, trying new things, and testing boundaries. They see play as a process of tinkering, experimenting, and exploring. These aspects of play are central to the creative learning process. Scratch was designed to encourage young people to tinker, experiment, and play with their projects. The Scratch programming blocks are tinkerable. You can easily snap the blocks together and take them apart just like Lego bricks. You can continually experiment and iterate your programming script this way. In my next video, I'll show you some examples of Scratch projects that exemplify these 4 P's of creative learning. See you then.